This line of text might look like a bunch of random letters mixed up and is unreadable to you, because it should be. This is called a ciphertext. A ciphertext is the resulting combination of letters after doing what's called an encryption. Encryption is basically taking a set of words or a sentence and then following a set of rules to scramble the letters of those words, usually by replacing them with other letters. To encrypt a message, we usually need two things. These are the cipher and the key. The cipher tells us what rules are needed to be followed to encrypt or decrypt words, while the key allows us to apply those rules in a logical manner following the cipher. For this example that I showed you earlier, the shift cipher was used in order to encrypt the sentence, "Math is fun." Shift cipher, also known as the Caesar cipher, moves the alphabet a certain number of times, which makes the key, then assigns the moved letters to the correctly arranged alphabet, resulting to the ciphertext. This cipher, however, is easy to decrypt even without the key, since we're only moving the alphabet a certain number of times, and there are really only 26 letters on the alphabet. Therefore, we can just test all the other 25 possible movements of the alphabet and decrypt the message. The shift cipher is an example of a monoalphabetic cipher, which means that each letter of the alphabet is assigned to another letter consistently throughout the whole text. Basically, scramble the alphabet, then substitute the letters with a different one. These kinds of ciphers are usually easy to decrypt, as I have demonstrated with the shift cipher. For a more effective kind of cipher, we need to use polyalphabetic ciphers. These kinds of ciphers can substitute multiple different letters to a single one. For example, in a monoalphabetic cipher, this letter F could be substituted by the letter E, and that continues throughout the whole text. However, in a polyalphabetic cipher, F could be substituted by many different letters along the whole message. Thus, the relationship of each letter in this kind of cipher is one to many. An example of a polyalphabetic cipher is called the Vigenère cipher. In this cipher, the key is actually a word rather than a number. For example, let's encrypt the message "Let's learn math" using the Vigenère cipher. Well, first, we need a Vigenère square. A Vigenère square contains arranged alphabet along rows and columns. Each row or column after the first will now be shifted corresponding to their place in the square minus 1. So the second column is shifted by 1, the third column is shifted by 2, so on and so forth. Next is we have to have a key. Let's use the word red. Since red is just 3 letters, we need to write it multiple times until the whole message has a signed letter to it, like this. After that, we go to the row of the first letter of our message, which is M, and move along to the right side until we reach the corresponding letter to it, which is R. We do this for every letter of the message to make it look like this. As you can see, the letters L, E, A, and T was all replaced by a different letter, even if they were repeated in the plain text, making this much harder to decode than the shift cipher. During the World War II, the Germans have created a polyalphabetic cipher using a device known as the Enigma machine. The Germans thought that it wasn't possible for the Allies to possibly break the code, as it would drastically change every day. However, a British mathematician named Alan Turing, along with his team, has created their own machine that would eventually break the Enigma code, leading the Allies to victory. Today, cryptography is used to protect your messages, emails, passwords, and even your bank accounts you use to excessively order online. With these, however, much more complicated and harder ciphers are being used since these are very sensitive information. Still, however tough a cipher is, there will always be a need for a key. Therefore, there's also a way to break ciphers every single time. That's why sometimes you hear news of hackers getting personal information from different companies holding lots of accounts of different people. So be sure to stay secure all the time. Thanks for watching.